Hey guys, I'm going to walk you through this lesson, but honestly, I think I probably could have done two things at once with this particular lesson. I'm kind of wondering if I should have put variables in with this square root of integers, but we'll just take it slow up. I think we have enough time to spend. Maybe next year I'll change it up. But today I'm going to teach you, and I apologize I don't have the keystone content, but I promise you this is on the keystones, how to simplify square roots that have integers. And in order to do that, we're definitely going to need our calculator, but we are also going to need to know our squares all the way up until 30 squared. So 1 to the second power, if you want to look at the calculator, is 1. And we're going to have to develop this list. 2 to the second power is 4. 3 to the second power is 9. 4 to the second power is 16. And we're going to make this list every day that we're on this. At least in my head, that's what's going to happen. So I'm going to go through and square all of these all the way up to 30. 7 squared is 49. And you can use your calculator if you want to pause the video and fill this in on your own. I have them memorized up to a certain point. Like I know 10 squared is 100. I know 11 squared is 121. And now, if you want to do it the long way, it's like 12 times 12. That's the same as 12 squared. So 12 squared is 144. You've already done these in previous classes, which is why I'm not teaching you like how to do it like the long way. And then 14 squared is 196. I'll change the size of this pen because the numbers are going to start getting pretty big. 15 squared is 225. I have a decent amount of them memorized. 16 squared, I think it's 256. Yeah, I don't want to get any wrong though, because that'd make the rest of the lesson bad. 17 squared, I think is 289, but we're going to double check. Now you might say, no, this is dumb. Why aren't you just giving me a list of my perfect squares? Well, because the keystones won't do that. You're going to have to, now there's no reason that you have to have these memorized at all on the keystones, okay? But on the keystones, 361. And you just see I'm squaring all the way to 30. You don't have to have them memorized, but when you get to square roots, you're going to have to make yourself a list if you don't know them by heart. So you can see this list is taking me, what, less than 5 minutes to make, and it could really benefit me in the long run. Now I will say, okay, let me make sure I say this about the keystones. I think if you just go to 10 squared, that's going to be enough for the keystones. I'm teaching you how to do bigger numbers because I figure, hey, if you know how to do it with the bigger numbers, you'll know how to do it with the smaller numbers. So I'll emphasize that again as I kind of write this stuff out. On the keystone, my guess is that you only have to go to like 10 squared. You might have to go to 15 squared, but this is a good habit to get used to. So whatever, okay, this one, let's see, 25 squared is 625, 26 squared is 676. And I'm just using my calculators for the ones that I'm not sure of, or even the ones I am sure of, just to show you the process. Okay, we're almost there. Remember on the keystones, like I said, you probably only need to go to 10 squared, possibly 15 squared. Okay, so 841. There. So squared just means you have the same thing times itself. And we made our perfect square list all the way up to 30 squared. Now, the steps are this. Check to see if the integer is a perfect square. If it is, just write the answer and you're done. So that would be step 1. Step 2, if it's not a perfect square, see what is the biggest perfect square. So see everything in the yellow highlights? You would see what the biggest perfect square, that's a factor of it. And then step 3, you'll write it as the product of those roots. You'll simplify the perfect square, step 4, and rewrite the answer. So for example, up here, the square root of 48 is definitely not perfect. Like it's not on my list. If you look here, 48 is nowhere. It goes to 49, right? It would be like in there. So it's going to be 6 point something, and it'll be close to 7. So since 48 is not on my list, I would have to figure out what is on my list, 16, that goes into 48. 16, by the way, is the biggest factor, the greatest common factor, or the greatest factor on that list. It goes into 48. 48 divided by 16 is the 3, and then the 16 becomes a 4, and the 3 stays trapped. It's just a lot easier if you just watch me do a couple. All right, so 25, here are 5 examples of perfect squares. The square root of 25 is a 5. If you look at my list, I'll highlight it here for you. The square root of 25 is just 5. So I'm not writing 5 squared, I just wrote 5. The square root of 25 is just 5. And look over here. You can see the square root's just a perfect 5. I can do the same thing here. The square root of 36 is a perfect 6. The square root of 49 is a perfect 7. The square root of 100 is a perfect 10. And the square root of 900 is a perfect 30. So I've taught you how to do what we call perfect squares. And if you have a list, you can just look like, oh, the square root of 900 is 30. Oh, the square root of 100 is 10. The square root of 49 is 7. So you can definitely make use of your list that way. But now look at these ones that are not perfect, okay? Non-perfect squares. So 160 is the first one, the square root of 160. Now let me type this on the calculator. You're going to notice that you get a really icky decimal, an irrational answer. That's because the square root of 160 is not perfect. See right here? Let's see. We have 169, but it's not 160. And we have 144, again, not 160. So the answer is going to be 12.6, as you see on the calculator over there, because it's somewhere between 12 and 13. But what on my list goes into 160? Well, the answer is, if you work your way down the list, like from the highest numbers to the lowest numbers, 16 is the first thing that goes into 160. Like you can do 160 divided by 16, and the answer is 10. So you have to find out what on this list, when I say this list, I mean this list right here, the yellow, what on that list goes into the number that's been presented to me. Okay, so the biggest thing that goes into 160 is 16 from the list. And then 16 times 10, that's how I did that, because 160 divided by 16 is 10. Okay. And then the square root of 16 is a 4, and the square root of 10 stays left over. Now, if you're given the square root of 6, look at the calculator. It's, again, an irrational answer. So the biggest factor on my perfect list that goes into 6 is 1. 1 times 6 is 6. So I did 6 divided by 1 equals 6. And then the square root of 1 is 1, and the 6 stays. You don't need to write the 1, just like you didn't have to do that when we were factoring. So 28 is not on the list. Look at the calculator, how it's icky. It's an irrational answer. So the first number on my list over here in yellow, the first number that goes into 28 is a 4, okay? So it would be 4 times, well, whatever 28 divided by 4 is. So I noticed that 28 divides by 4, and I got a 7. Well, the square root of 4 becomes a 2, and the 7 stays trapped. This continues to happen. So if you're presented with 120, the square root of 120 doesn't work. The biggest thing on this list that goes into 120 is a 4. So you take a look. You might think 36 goes into 120, not evenly. You might think maybe 16 goes into 120, not evenly. So the first thing that goes into 120 evenly is a 4. So that's why I wrote 4 times 30 here. Remember, I did 120 divided by numbers until I got one that worked. So I got 120 divided by 4 is 30. That's where the 2 and the 30 come from. The square root of 500, the first number on my list, the biggest number on my list that goes into 500 is 100. So I do 500 divided by 100 is 5. So there's my perfect square, there's my leftover. The square root of 100 is a 10, and the 5 stays put. All right, now it's time to try a couple on our own. So I have this list right here. I think I have them memorized enough that I should be able to, and something you might actually want to do is screenshot this and just have this permanently ready to pull up. All right. So I'm going to put that list here so I don't have to keep going back and forth to my pages. There it is. All right, and I'm just going to put it here by the 87. Okay, so notice what I'm going to do is keep this in shot. Now, I'm going to do 87 divided by, now you might say, well, where in the world do you start, Mrs. Lanchelli? Well, I start halfway of 87. So I'm going to start somewhere right around here. So I know that 49 is not the answer, but I'm going to show you why. 87 does not divide by 49. So then I'm going to make my way to the next lowest number on the list. So I'm going to go to 36. Does not work. Next lowest number on the list is 25. Does not work. Next lowest number on the list is 16. Does not work. Next number down the list is 9. Does not work. Next number on the list is 4. Does not work. So believe it or not, the only thing that goes into 87 is the 1 times the 87. So I'm going to have the square root of 1 times the square root of 87, which is 1 square root of 87 at the end. 87 is prime. No, it's not prime. There's no perfect squares that go into it. Yeah. All right, number 2. So I'm going to erase all this extra marks that I have here. I'm going to take my list and just drag it over to number 2. So what goes into 810? So I'm going to start about halfway of 810, so in like the 400s, okay? So I'm going to do 810, and I'm going to divide by 441. Then I'm going to do 810, and I'm going to divide by 400. I'm just making my way up the list. So I'm going to do 810 divided by, what's less, 361. So I'm just going through these numbers. So no, I'll do 810 divided by 324. And now I'll do 810, oops, that one didn't work today. 810 divided by 324. Closer though. 810 divided by 289. Making my way down the list. 810 divided by, where am I at? 256. 810 divided by 225. 810 divided by 196. 810 divided by 169. 810 divided by 144. 810 divided by 121. 810 divided by 100 won't work. How about 81? There it is. It's 81 and 10. So I'm going to do this. Instead of writing it like that, I'll do it as the square root of 81 times the square root of 10. The square root of 81, my list says, is a 9, right? So this becomes a 9, and then the square root of 10 drops behind it. So that's how you reduce to square root. Now let's try number 3. We're going to go to 52. So 52, this time on my list, the number's not quite as big. So about half of 52 is in the 20s. So I'll start here at 25. Now I know that's not going to work, but I want to show you why. Now let's see, what's after 25? I got 16. That's not it. After 16 is 9. After 9 is 4. Oops. And there it is. So we're going to rewrite 52 as the square root of 4, because that's what worked from the list, times 13. Square root of 13. The square root of 4, my list says, is a 2, and then the square root of 13. So the square root of 4 is a 2, and then the 13 drops down. All right, we're just going to keep this process up. Now we're going to do 300. So half of 300 is like 150-ish. So I'm going to start here at 140, okay? So I'm going to do 300 divided by 144. 300 divided by 121. 300 divided by 100. And I get, there's my answer. So instead of seeing it as 300, I need to see it as the perfect square that worked and what I got as an answer. So the perfect square that worked was 100, and I got 3. So the square root of 100 is 10, and then the square root of 3 drops down. We're going to continue this process through number 5, 117. So half of 117, and if you're not sure what half of 117 is, just divide by 2. It's like in the 50s. So I'm actually going to start at 49. That's my starting. I'm going to work my way into the lower numbers. Okay, so 117 divided by 49. No, 117 divided by 36. 117 divided by 25. 117 divided by, what's next? 16. Just so you guys know, odds will not divide by even. So from now on, if I have an odd, I am not going to divide by an even. 117 divided by, what was my next number? 9. Is that going to be the tick? There it is. So it's 9. So I worked my way through my list. The first one I got to work is 9. So I'll write the square root of 9. And my answer was a 13. Look at my calculator. So 9 worked. 13 is what I got, because 9 times 13 is 117. The square root of 9 is a 3, and the square root of 13 drops down. And that's how you simplify that square root. Now it's time for number 6. So number 6, I have an odd number. Holy cow, it's a super large number. So what I'm going to do is I'm just going to start way at the bottom of my list. I didn't make any of them bigger than 300. So I have 4235. Oh dear, 4235 divided by, I know it's not going to be 900, but what about 841? Bummer. 4235 divided by maybe 729. So what I'm doing, guys, is I'm just making my way up. I'm using the odds because an odd will not divide by an even. Let's see, I messed something up there, didn't I? 4235 divided by 729. Nope. 4235 divided by 625. That's going to be a no-go. 4235 divided by 529. No. 4235 divided by 441. No. 4235 divided by 361. 4235 divided by... I'm just making my way up the list. I know it has to be an odd answer. All right, so I'm going to do 289. Odds will divide by odds. Where was I at? 289. Let's try 2. No, it's not. Maybe it is 225. Nope. I made these problems. You think no, I wouldn't have these memorized. There'd be no way to have all these memorized. What's the next one up? 121? Ah, I got it. So it's 121 and 35. That was a long list. So instead of writing it like that, let me look at my calculator. The first number on my list that worked was 121 and then 35. So this turns into an 11. See that on my list? 121 turns into 11. And then the square root of 35 drops down. That's how you simplify that square root. All right, let's do 48. Let me erase all this stuff. All right. Now, 48 is even. Evens could divide by odds, so we're going to have to check everything. Half of 48 is 24, so I'm going to start at like 25, okay? I know 25 won't work, but we'll do it anyway. Then my list, let's see, is 25, 16, all right? So 48 divided by 16, there it is. So it's 16 and 3. So instead of writing it as 48, because that's icky, we'll do 16 and 3. Now look at what I mean by it's icky. I mean it's irrational. See how it's like a gross answer? So it's not perfect. So the square root of 16 is a 4, and the square root of 3 drops down behind it. Number 8. Okay, so now I'm going to start with, look, I'm going to do the square root of 864. Bummer, it's a decimal, so I need to go and try to figure out what goes into it. So we're going to start in like the 400s. I'll do 484. Okay, so I have that in view. So 864 divided by, I'm going to start at 484. 484. No. What am I at? 864 divided by 441. No. 864 divided by 400. That's not going to work. 864 divided by 361. That's not going to work. 864 divided by, where am I at? 324. Is that my next number down the list? Good. 864 divided by, where I just did 324, so now I'm going to do 289. Nope. 864 divided by 256. No. 864 divided by 225. No. 864 divided by 196. No. 864 divided by 169. No. 864 divided by 144. Yes. So finally I got, instead of writing it like that, because that was irrational, I need to write it as the product of its perfect square and its leftover. So the square root of 144, my chart tells me is 12. And then I have the square root of 6 behind it. And we're going to repeat this as we go along. So how many more? I have a few more for you, okay? You might say, oh, I've got this process. But what happens is kids don't trust this process and they just like fly through it. And it costs them getting the right answer because they'll pick something that's not the biggest answer. So if you want to see it, maybe 350 is a perfect square. Well, it's not because it's not on my list, but you can see there on a calculator. So 350 is about 175-ish is the middle. So we're going to go to, I'll try at 169, okay? So I'm going to keep 350. I'm going to try 169. 169, no. 350 divided by 144. Whoopsie. That's a no-go. 350 divided by 121. No. 350 divided by 100. That's going to be a no. 350 divided by 81. That's going to be a no. 350 divided by 64. That's going to be a no. 350 divided by 49. That's a no. 350 divided by 36. Oops. That's a no. 350 divided by 25. There it is. So it's 25 and 14. So I'm going to do this as 25 and 14, both in the square root. That's because you're allowed to write it like that. And then this becomes a 5, and that becomes a 14. Now, if you're taking the keystones and you want to like prove that you're right, watch this. If I do the square root of 350 in my calculator, I get that as a decimal, right? So what was it? 18.71-ish. And if I do 5 square roots of 14, look, I get the same decimal. But you can't really trust that method because it would work even if you picked like not the biggest answer, but at least you know you have the right product. But it might not be the greatest product. So you had to be careful with that. All right, now what we're gonna do is go to the next one. I tried to convince my daughter to come help me with my video, but she didn't want to. All right, so I'm gonna do 1944 now. And I'm going to start all the way at 900. That will not be the answer. 1944 divided by 841. You can say hi to the kids.
Hi to the kids.
No one's listening anyway. If you are listening, come to me. I'll give you a bonus point. 1944 divided by 729. I was going through the list. Do you know what I'm doing? Making my way through the list. So I'll do like I'm on this one. So I'm going to do 1944 divided by, I just did 729, so I'll do 676 now. I'm looking for something that goes in evenly. What am I going to divide by next?
I'm going to guess 625.
Isn't this fun? There's a different way to do this, but like kids have to be able to divide really well, and I just have noticed in my career that that's just like not a thing. I mean, hey, but if any of you are like, hey, Miss Langeli, that's insulting. I can divide really fast and really well. Then come to me. I'll show you the shortcut. Well, actually, it's not a shortcut. It just is a different method. What's next? Can you tell?
400.
So then just making my way through the list.
I have a good feeling about this one right here. Nope.
What do you think it is?
I haven't been thinking about it.
I bet it's this one. Oh, nailed it. All right. So instead of writing the square root of 1944, I'll write this double square root of the one that worked. So what worked?
324.
And then what did I get as an answer?
6.
Because what's 324 times 6?
Apparently 1944.
That's exactly how it works. So you're not changing the RAM, you're just like rewriting it like water and ice. So the square root of 324 is, can you
18.
tell from my list? Yeah,
wow.
And then the square root of 6 just drops down. All right.
Look at this.
216. Okay, we're getting there. Okay, so 216, you have to start about halfway. So I'm going to start at like 144. Okay? That makes sense? So I'm going to check. When I do this in class, I think what I'm going to do is I'm going to highlight where I start, and I'm just going to draw an arrow like this. Does that make sense for them? Okay. So I'm going to do 216. And where did I say I was starting?
144.
Okay. Now, did that work or not?
No.
Because you got a
decimal.
Okay, did that work?
No.
Because you got
a decimal.
And I try 100. Nope. Did that work?
No.
What should I try next?
I guess 81.
Okay. Did that work?
Nope.
Okay. What's next?
64.
Okay, so you caught on. Did that work?
No.
Okay, now what do I try
49.
next? Okay. And did that work?
Nope.
Okay, now what do I do next?
36.
Okay. Did that work?
Yes.
Okay, so it's 36 and
6.
Which is okay because I'm writing the same thing in a different form. I'm just breaking it down to its factors. This one's the perfect factor, and this one's what I call the leftover. All right, what's the square root of 36?
6.
Okay, so this item becomes a 6 times...
Square root of 6.
Yeah, okay, good. You got the lesson. So if you were able to do that as well as my husband, you could probably check out at this moment. No, don't, because we have to do the algebra one.
Oh, yeah.
That was intense. Okay, I feel like you were able to, let's do one more. Let's make sure they can catch on. Because if you can do this, then they can do this, and I don't have to do the last 4. Okay, you ready? So is this on my list? Or actually, hold on. Watch. Look at the answer to the calculator. I just want you to say yes or no. Do you think that's a rational root or not?
No.
No, it's not. See how it was it icky decimal when you typed in? That means we need to go through the list.
Well, let's not give decimals a bad name here.
No, most things in life are decimals. Okay, so we're going to start at 900 because half is like 2, and we're going to work our way up. Okay, ready?
Got it.
Or down, however you see that. Okay, so what do I type? 2420 divided by 900. Did it work?
No.
Okay, 2420 divided by
841.
841. Did that work?
Yes, just kidding.
2420, what do I do now? Divide by
784.
7. Oopsie. Did that work?
Nope.
2420 divided by
729.
729. 2420 divided by
676.
This is good. And next, 2420 divided by
625.
625. Did it work?
No.
2420.
576.
Okay, 576. Answer.
Nope.
2420 divided by
529.
529. Did that work?
No.
2420 divided by
484.
484. Oh, it did it. Okay, 484 and 5. So we're going to write it as a product of its factors. One of them being the biggest perfect square, 44 times a 5. What's the square root of 44? Can you see on there?
22.
That's right. So this turns into 22 square roots of
5.
All right. I feel like that's enough.
I'm with you.
Okay, now we're going to go old school algebra 1 that they learned in the class before me. Okay, but you know this.
Y equals mx plus b.
That's right. This is y equals mx plus b. So
Rise
what do
over
we
one.
what do we graph first?
I'm gonna guess your b, or is that your y-intercept?
Yes. So you go to your y-axis and you go to 5. And then what do I do with the negative 3?
Is that down 3?
Down 3 and
over 2.
Over 2. Boom, 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 boom. Boom, 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 boom. I said 3's plenty. I mean, especially because you got this really nice line tool here.
Well, what kind of line did you draw there?
That's
I
perfect.
fixed it for you.
All right, there. Looks good?
Beautiful.
And anything on this line is a solution,
Yes.
meaning that it would plug back into that
And it would be
equation.
true. Yes.
Yes,
Yes.
All right, ready? I got to
Ready.
solve for x first. What should be my first
is
step?
this an inequality?
Yes, because it doesn't have an equal sign. Good, it's inequality. Tell me what to do first. I want that 5x to go to the other side. I'll tell you that.
You want that 5x to
I'm
the other
picky.
side?
Yeah, I think it's easier for kids.
So just subtract 5x from each
Subtract
side?
5x.
Mm-hmm.
Okay, what is my resultant inequality?
So negative 2x minus
3
5
minus 5.
is greater than 7. Then we're going to do add 5 to each side.
Move the constant to the right.
So negative 2x is greater than 12.
Okay,
Then divide by negative 2.
that is correct.
So then x is greater than negative 6.
Lesson.
Oh, because you divide by negative.
Divide by
I knew that
negative.
rule.
I know you did. I didn't say it because I wasn't sure. I thought
I
but
should've.
I'm so impressed by you. All right, so I'm just going to shrink that down because I think that, I don't know, I thought that was pretty good. Did you think that was pretty good?
Well, since I did it, yeah. I
Okay.
think-
So I don't know how to shrink it down. I guess I'll just, maybe I won't shrink it down. I'll just change color. Okay, so we'll put negative 6 in the middle. Who cares, right? And then negative 5, negative 4, negative 3, negative 7, negative 8, negative 9, etc. Open or close circle.
Open.
That's right. And because we flip the sign, it's less than. Where does it point?
Less than to the left.
So everything under that arrowhead is a solution. And that's how you graph the solution. But don't include negative 6. Negative 6 is not part of it because it's open there.
It's going to be less
All
than
right.
negative 6.
Do you remember, is domain X or Y?
Ooh. I know you got domain and
Hint,
range.
the word is in X or Y typically. Do you plug in for X or do you plug in for Y typically?
I'm going to say x.
Yes. Okay, so domain is the X values. So we're looking from what is the leftmost, so left to right. Okay. What is the leftmost of this graph goes? Here's
I'm gonna
your
say negative 2.
x-axis. Yeah. Okay, so negative 2 is where it starts on the X. And where does it go to on the x-axis? So it goes here to
Positive 2.
positive 2. So here's what we're going to write. See that there?
Mm-hmm.
So it goes from negative 2 to positive 2.
Mm-hmm.
It's X values. And this one is anything less than 2. This one's greater than or equal to. Why do you think I didn't put a line on that one?
Because that's an open circle.
And why do you think I did put a line on
That's
that one?
a closed circle.
And that is the domain. All right, I think that was good enough. So we did 3 main concepts. They did this in chapter 5 with their previous teachers. They did this in chapter, I think 3, and then they did this in chapter 4. So we got some good reviewing. Looks good to go?
Great.
Okay. So steps are find the biggest perfect square, not just a perfect square, find the biggest perfect square. My method I showed you works, like working from the bottom up. And then whatever you get after you divide, take the square root of the first item, and then the other item just drops down.
Wonderful.
Cool beans.